All right, so before we stop, we learn diode and transistor. So in transistor, we have NPN transistor and PNP transistor. Even though most of the time, question in SPM, it always NPN. Reason? I don't know why, but it's always NPN. You can look back at your question and it's always an NPN, even for the question like this one. Okay, so next is, I want to go to the calculation. All right, before we go to the calculation, it's like this. Okay. So transistor can be used as amplifier, okay, in the process of amplifier, and also used as an automatic switch. So most of the time, used as automatic switch to light up a bulb, okay, during the days or night. Okay. So what you need to remember is, if the LDR is light dependent resistor. So the resistance changing with intensity of light. Okay, that's why it's light dependent resistor. The resistor depend on light. Okay. So what I ask you to remember is, okay, is it will light up based on the position of the LDR. Like this question, tell you that the diagram show automatic switch circuit to light up a bulb during the daytime. Okay, so it's during the day. And you see, during the day, because the LDR is at the top. What change should be done to light up the bulb at night? Okay, what change should be done to light up the bulb at night? So to light up the bulb at night, you just need to, what is your opinion? So you need to change the R1 and LDR. Okay, good. Akasha, okay, good. Good try, Akasha. The answer is A. Okay. So this one, if C, B, and E have the usual meaning for a transistor, which one of the following transistor is correctly labeled? Okay. Which one is correctly labeled? So first, my question is, what type of transistor is this? What type of transistor? Okay, transistor is NPN. Okay, good. So the transistor is NPN transistor. So the answer is C. Okay. We are going through this question, but to understand this question, so this is question that come out in paper 2 SPM. It's like this. Okay. So relate to calculation. Okay. You might snap the picture, or it's okay. Later I send you this. Okay, later I send you this. So first, my question is, this one, my question is, name the type of transistor. So the first question asks you the type of transistor. You see, still use the NPN transistor. Okay. Next, name the resistor X. What is the name for the resistor X? Okay. Good. Aina said in the chat that resistor X is LDR, like dependent resistor. Okay. Now it came to the next question. Question state that the resistance of X is 40 kilo ohm in the dark environment. Okay. So first, I forgot to ask you, when will the bulb light up? When will the LED or the bulb light up? In this question, they put an LED. So this is a symbol for LED. Okay, LED. So when will light up? Okay. When will the LED light up? During night or during days? Okay. During night or during days? Aina during days. Akasha during night. Christina during night. Okay. So, dia macam ni. LDR atas, siang. LDR bawah, malam. Sebab kita bermula siang dulu baru malam. Okay. Siang dulu baru malam. Ni atas, siang, bawah, malam. Okay. If LDR is at the top, during days. If LDR at the bottom, during night. Okay. So now LDR is at the bottom. So it will light up during night. Okay. So you see, stated there, the resistance of resistor X is 40 kilo ohm in dark. So the question tell you that this one is 40 kilo ohm. So the question A is calculate potential difference across B and C. Meaning the question want you to calculate what is the volt here. Okay, what is the volt here? So to understand this, basically we go to the basic of circuit. Okay, basic of circuit. It's like this. If I have a battery, okay, my pen got problems. Okay, this one is 6 volt. I said this 10, this is 40. Okay, my question is, so this is electric. Okay, this is basic electric. My first question is, how much current flow? Okay, how much is the current flow? Try to calculate how much is the current flow. Zero 0.12. Okay, good. 6/50, okay, good, because I is V over R. So V is 6, but R is the total resistance, which is 10 plus 40. So you get 0.12 ampere. Okay. So this is a series circuit. Okay, this is a series circuit. So if series circuit, current will be the same. Meaning, Okay, meaning how much a current flow here is 0.12, current flow here 0.12. Okay, same. So based on the same principle, meaning okay, V that flow in resistor number 1 over resistor number 1 is equal to the V that flow resistor number 2 over R number 2. Okay, because the current is the same. Okay, because the current is the same. Right. So using this formula, you can calculate here. Oh, sorry. Yes. Okay. Again, V total over resistance total equal to V1 over resistance number 1 equal to V2 over resistance number 2. That's the equation. Because both have current total and current flow to resistor number 1 equal to the current flow in resistor number 2. So because of that, Vt over Rt equals to V1 over R1 and V2 over R2. Okay. Based on that principle, you can find the potential difference across BC. So across BC, so V total over R total equals to VBC over RBC. So V total is 6 and the R total is 10 plus 40 kilo. Okay, kilo over VBC over RBC. RBC or R at the LDR given by 40K. So find the VBC. Okay, find the VBC. What is the BBC? Okay. What is the value for VBC? Anyone? 4.8 volt. Okay, Aina state that VBC is 4.8 volt. Okay, good. So this is 4.8 volt. So you see, the total is 6 volt. The total is 6 volt. For VBC is 4.8. So VAB is the balance of it. Okay. So it's the balance, meaning, so this one is 1.2 volt. If you add up both, 1.2 plus 4.8, you get 6 volt. So basically, this question, if it came out in paper 2, is not about electronic. It's about electric. You just need to, okay, to think that all this in the middle doesn't exist. So you just use a formula which is related to electric. I hope you understand, because most of the student, when they see this question, they doesn't know which formula to use because there's no formula teaching how to find voltage, resistance in electronic. Okay, all that voltage, resistance, current is learned in chapter electric. So you need to differentiate between chapter electric and electronic. Okay. So last question is explain why light emitting diode light up when resistor X is in the dark or when the LDR is in the dark. Okay, so jot down this one. Okay, jot down this one. So during dark, what happened during dark? The resistance R, okay, resistance of the LDR increase. Okay, so when the resistance in LDR increase, voltage across LDR also increase. Current will flow through the base of transistor. Okay, current will flow the base of transistor. Number 4, transistor is switched on and LED will light up or LED or bulbs. Okay, so during dark, resistance of LDR is high or increase, voltage across LDR high or increase, base current will flow through the base and transistor will switch on and LED will light up. Okay, because as mentioned earlier, even though the current flow through the top, flow here, flow through the LED will not light up until there a current in the base. Okay, when there's a current in the base, this one will turn on, so current can start to flow through the transistor and the circuit will complete. So this bulb will light up. Right. So that's the basic for the transistor. Right. Last subtopic is get logic. Okay. So any question related to transistor? Okay, thank you, Aina. Okay, last part is get logic. Okay. Get logic is not like transistor, it's not like diode, there's a component. Get logic basically is like one system that consists of transistor, diode, and every other component that do logic output. Okay, where you find this? Most of the time is in sensor. Example, logic gate being used in shopping complex where you want to enter the parking, there's a barrier there. Okay, so the logic behind the barrier is you need a car to be parked, okay, in front of the barrier. There's a car and you need to push the button, the ticket button. So if there is a car and you push the button, then the barrier will lift up. Okay. If you have a car, but in front of the barrier, okay, you drive through then you don't push the button, the barrier will not lift up. Or you don't have a car, you just walk to the barrier and you push the button, same thing, the barrier will not lift up. Okay. And shopping complex, the door of shopping complex, also a logic gate. If there is a person and the person walk through, then the door will open. That's a logic gate. Okay, so you do a logic. Same thing with your seat belt. Okay, you seat belt. If you what we say? If you sit on the car in the driving seat, okay, in the driving seat, then you don't put a seat belt. If you don't put the seat belt, there will be a sound, okay, to show that you need to wear the seat belt. If you sit and wear the seat belt, the sound will not produce. Okay, that's a logic gate. But in SPM, the logic gate is really simple. You need to remember three gate, the basic three gate. So the first gate is not. Okay, not, you have one input and one output. So not is like it always does not believe. I mean, if you say zero, no, you say one. If you say one, no, zero. So that is not gate. It will change what is the input. You say zero, one is zero. And logic gate only read a binary. Binary mean only read two numbers, 0 and 1, 0 and 1, 0 and 1. Okay. Second one is N. So N bentuk dia, shape is like D. Okay, there's two input and one output. So D darab. Okay, D darab. So darab input. So 0 and 0 will be 0. 1 and 0 will be 0. 0 and 1 will be 0. 1 and 1 will be 1. So that is N. Okay. If you have N and you put the dot is for not. Meaning, what is the output for N? What is the output for N? You replace with, you make it not. Meaning, you know that N is 0, 1, 0, 1, 0, 0, 1, 1. The output will be 0, 0, 0, 1. So you make it not. 0 become 1, 1, 0 become 1, 0 become 1, 1 become 0. So this is the output. Okay. So you doesn't have to remember the none. You need to remember N. Okay. If you remember the output for N, so you change the output for N, okay, you not the output for N, you get none. Okay. Or. So to get OR is A plus B. A plus B, you will get X. So 0 plus 0, 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1, even though it's 2, because it's binary, produce 1. So for NOR, there's a dot here. So the output will be same, 0, 1, 0, 1, 0, 0, 1, 1. You get 0, 1, 1, 1. You make it not, it's 1, 0, 0, 0. Okay, that's three important. The other two is just for you to know. Okay. Okay. Let us do the question. Okay. Stop doing this. We do this question. Okay, for logic gate. Right. I think it's better the one that I shared earlier. Oops. Sorry. Okay. So we go to this one. Which one I think is better? The betterment is okay. It's okay. We start with this one. Okay. So we start like this. If this is 0, okay, if this is 0, meaning 0, there's two legs, 0 and 0. If we start with 0, also same thing, 0 and 0. So this is n, but there's a dot, so it become none. But don't worry, we start with n. So n, you need to multiply, darab. 0 times 0 is 0, but there's a dot here, meaning become 1. Okay, 0 or 0, b plus 0 plus 0 is 0, but because there's dot here, become 1. So p is 1, q is 1. So 1 and 1, this is all. 1 plus 1 is 1. Okay. Next, we start with number 1. 1. Okay. Okay, 1 and 1. So 1 here and 1 here. 1 times 1 become 1 because there's a dot here. Minus becomes 0. Okay, 1 or 1. 1 become 1. Okay, dot here becomes 0. So if 0 and 0, the output is 0. Okay, next, you find the answer. What is the answer? Oh, basically that's really easy. Okay, because R is not. Sorry, R is O. So O if you plus. This is wrong. This is correct. This is correct. Why I becoming blue? See, I didn't read the question. I didn't read the question. Okay. The question state that if the logic state of A is 0. See the effect of didn't read the question? If A is 0 and B is 1. Okay. 0 and 0 you times, you get 0, but there's a dot, become 1. So this is 1 and 1. Okay, this is 1 and 1. So 1 and 1 you plus become 1, but because the dot becomes 0. So 1 and 0. So 1 and 0 is 1. The answer is B. Okay. All right. So you might try the other question for logic gate. Okay. Oops, why? Let me share you this. Okay, so example of this. Okay, given here the input and output. So state that if x 0, okay, if x is 0, y is 0, so this is become 1, and 0, 1, the z is 1. Okay. And then when 0, 1, so this one becomes 0, 0 and 1 is 1. So the question is, what is the logic gate of M? Okay, what is the logic gate of M? Okay, 3 is, this is 1. If this is 0, so this is not, become 1. 1 and 1, the output is 0. Okay, last one, this is 1, this is 1, this is not. So it becomes 0, 0, 1, become 1. Okay, the question asks you what is the logic gate. Okay, so see the output here, compare the output here. Okay, D. Alright, so I nested D 0 1 1 0 0. This 1 1 1 0. 1 0 is 1. Right. So basically 0 1 0 1, okay, 0 and 1 you get 0, you get 1. And then they said that 0 and 0 you get 1. 1 and 1 you get 0, but 1 and 0 you get 1. Okay. So if you have an output like this, meaning this is either none or no. Okay, either none or no. Why? Because if 0 plus 1, okay, 0 plus 1 is 1, that is all. If plus become 1 is all, but this one, you time this first, you get 0. Okay, you time this, you get 0. You time this, you got 1. You time this, you got 0. So this is basically output for n, but at the back is output for none. Okay, so the answer is A, none. Okay, you might try all the other question also. Okay, in paper 2, we have a question of this one. In paper 2, I give you already. But basically, this is the same question as we answer in paper 1, almost the same. So first, name the electronic component of A. What is the electronic component of A? What is A? Okay, what is A? Oops. Aina, is it transistor? Christina, okay, good. It's a diode. Okay, A is a diode. So what is A is a diode? Explain why the bulb does not light up. Why the bulb does not light up? Okay, why the bulb does not light up? Yes, good, because the arrangement is in reverse bias. 1 mark. There's 2 mark there. Reverse bias. So what happens when reverse bias? Current can't flow through transistor. Tak boleh lalu transistor. Okay. Suggest one modification made to the connection so that the bulb will light up. Sorry. Diode. Touch. Thank you. Saja je cikgu test. Tengok perasan ke tak. Okay. It's diode. Okay. Saja test. Alright. Reverse bias. So current cannot flow through the diode. Right. Suggest one modification made to the connection so that the bulb will light up. So apa kita nak buat to make sure the bulb is light up? There's two way actually. Either you said changing the pole of battery, or you can also reverse the battery or reverse the diode. There's two way. Reverse the battery or reverse the diode. Okay. So this one, complete all four spaces given in the diagram with electronic component A to produce a full wave rectifier circuit. So full wave, you need 4 diode. Remember the arrangement is like this. Okay. Mula-mula dia dua-dua tak pandang diri masing-masing. Okay, dua-dua tak pandang. Then bertemu kembali. Okay, dia macam berpisah, bertemu kembali. Okay, drama Melayu sangat. Right? So that's arrangement of the diode. Okay, a capacitor is arranged in parallel to produce a better result. What is the function of the capacitor? As I told you earlier, the capacitor is to smoothen the circuit, right? So the smoothen the circuit. Okay, so this is the question, basically the one that we tried before. You might complete this afterwards. And that's all for this chapter. Okay, so I hope today class help you a lot. Try to do more question, and if you have any further question, you can ask in the group, and I will try my best to answer all your question. Okay, you can snap your picture and everything, every question you want to ask is okay. Okay, selamat berpuasa, selamat berbuka. See you tomorrow. Don't forget, tomorrow is a chemistry. Okay, tomorrow chemistry class. So see you.